Hello friends, you might be aware that in 2018 India had its first edition of highway capacity manual, and this manual was developed with funds support from CSIR. I will describe the important features of this manual in this presentation. The basic premise of development of this manual was that the Indian traffic characteristics are fundamentally different from those in developed countries, and also the driver behavior is vastly different from even the developing countries like China, Taiwan, Malaysia and Indonesia. And therefore the objective of this study was to study the nationwide road traffic characteristics and to bring out a manual for determining the capacity and level of service for various types of interurban roads and urban roads, including intersections and pedestrian facilities. It has covered in undivided roads like single lane, intermediate lane, two lane, divided multi-lane highways, expressways, and also urban roads, controlled and uncontrolled intersections, pedestrian facilities, and a new concept of travel time reliability is also introduced in one of the chapters. Since this was a huge task, a single agency cannot do it, and therefore it was a network project coordinated by CRRI, and different institutes were involved, including IITs and NITs. The manual has 10 chapters, and each chapter is devoted to a particular type of facilities, like chapter 2 for single lane, intermediate and two lane roads, chapter 3 multi-lane highways, chapter 4 expressways, 5 urban roads, and so on. Now I'll simply describe what are the new features which are introduced first time in any manual in the world. And the first is the concept of dynamic passenger car unit, which was based on area and speed of a vehicle. And this concept you must have read in several papers of mine, and it has been widely referred by researchers in India and abroad. PCU for a type of vehicle I is given by the speed ratio divided by area ratio of the vehicle with respect to car. And this concept was used to derive PCU factors for single lane and intermediate and two lane roads, and these are the values which are suggested in the manual. These values are different from the values which are given in IRC code. Another new concept which is introduced in this manual is of stream equivalency factor. Now you need not determine PCU for individual vehicle. Rather, you can find out what is the overall PCU factor for the entire traffic stream. So what we did here, we plotted flow in PCU per hour and flow in vehicle per hour. Now this is what actually measured in the field, and this is after converting flow into PCU using dynamic passenger car unit values. And you can see here that there is a very poor correlation between these two values, and it is mainly due to the fact that PCU for a vehicle type will depend upon traffic composition, and therefore a equation like this is suggested in the manual: 1 plus sigma I AI into Pi plus AN 1 upon n, where Pi is the proportion of the vehicle of type I other than a standard car, AI is a coefficient, and AN is also a coefficient, and n is the total volume on the road in vehicles per hour. So if you know only traffic composition and traffic volume, you can find out what will be the overall equivalency factor of the entire stream, and you need not calculate the PCU factor for individual vehicle. You can do it for two lane and intermediate lane roads using this equation: PBC, big car, two wheeler, three wheeler, LCV, and so on. These are the proportions. and you can find out K values, and once you know the K value, you can multiply the flow in vehicles per hour by this K factor to get flow in PCU per hour. Similarly, this is the equation for single lane road. Here we consider a lesser number of vehicle categories which are generally found on single lane roads in India, and the summary of capacity values for single lane, intermediate lane and two lane roads. And again I would say that these are different from what is given in IRC 64. Now you can see here that the capacity of any type of road changes from, let us say, for intermediate lane road from 1456 to 2082. Now what we found that the capacity depends upon the condition of the road also, like roughness. So we try to correlate this capacity with the operating speed of car, because any change in the road condition will be reflected in the speed of the vehicle, and therefore operating speed here is 85th percentile of free flow speed, and this is the kind of correlation between the lane capacity and operating speed on two lane highway, and this is the correlation between operating speed and IRI on two lane and intermediate lane road. So if you know IRI, you can estimate the operating speed on a two lane road or intermediate lane road, and from this estimated operating speed you can find out the capacity, the lane capacity. Similarly, for two lane roads, a new LOS parameter has been defined in the manual, and that is number of followers per capacity, NFPC. Because the parameters which are used in literature, particularly in highway capacity manual of US, they were not found suitable for mixed traffic conditions, and this I have explained in detail in my another video, which is on LOS on two lane roads, and you can see that video to understand the concept of level of service on two lane roads. But here I would say that the number of followers can be estimated using this equation if you know traffic volume on the road, where Q is two-way traffic volume in PCU per hour and NF is the number of followers in PCU per hour. This is the table showing the proposed LOS ranges for intermediate and two lane roads, and this is for single lane road. Now for single lane road, V by C ratio is suggested because their number of followers were not found to be correlated very well with the V by C ratio or level of service, but in case of intermediate lane road and two lane road, we suggested NFPC as the LOS parameter. And for simplicity, for understanding by field engineers, these values are also correlated with V by C ratio on two lane and intermediate lane roads. For multi-lane highways, density is taken as the parameter for defining the level of service, and I have another video on this LOS on multi-lane highways. You can watch for complete details on this topic. For urban roads, we have considered three types of roads: 4-lane divided, 6-lane divided and 8-lane divided, and the capacity value which are given in the manual are given in this table: lane capacity, or you can say directional capacity. And for urban roads, we have considered different types of frictions. This is the carriageway width, friction due to on-street parking, friction due to bus bays, and friction due to curbside bus stop. And a correction factor is given in the manual to adjust the capacity for these friction factors. The level of service criteria is based on the speed on the urban street, and if it is more than 53 km per hour, we define level of service A. If it is less than 19 km per hour, it is level of service F. Now in case of roundabouts, we considered a new method to find out the critical gap. And this method I have explained again in my another video on critical gap on roundabouts. You can watch that video to have deeper understanding of the method, but here I would say root mean square method is developed to determine the critical gap of a vehicle at roundabout. And this method suggests that this is the accepted gap distribution curve and this is the rejected gap distribution curve. Then the critical gap distribution curve will lie between these two in such a manner that the root mean square error of this Tc minus Ri and Ti minus Tc will be minimized. That is the equation. So it was optimized and Tc was calculated. Once you know the Tc, then you can find out the capacity, entry capacity of an approach using the same equation as given in highway capacity manual of US. And here Tc and Tf are two parameters. Tf is taken as a proportion of Tc and the capacity can be estimated. This is the generic model for two-lane approach roundabout. The capacity, entry capacity will change with circulating flow, and this is how the bandwidth of the variation in the capacity. And similarly, this is the generic model for three-lane approach capacity. Now, level of service at roundabout is defined in terms of average delay per vehicle and is the table which provides the ranges for different level of service. The next chapter of the manual is on unsignalized intersections, and here the movement is based on gap acceptance process. And you might be knowing that in US capacity manual the ranking of movements is defined. If this is the major street and this is the minor street and these are the movements, and on these four approaches, rank 1 movement is 2, 3, 5, 6, that is through traffic on major street and left turn on major street. Rank 2 movement are 1, 4, 9, 12, that is right turn from major and left turn from minor. Rank 3 movement are 8 and 11, that is through on minor street, and rank 4 is 7 and 10, right turn from minor street. Now what we observed in field in Indian conditions, that rank 3 and rank 4 movements are interchanged, and therefore rank 3 movement is 7 and 10 and rank 4 movements are 8 and 11. We introduce a new concept of occupancy time method to calculate the critical gap at uncontrolled intersections, and I have covered this concept in full detail in my another video on critical gap and unsignalized intersections. You can watch that video for deep understanding of the method. And we found that critical gap varies with percentage of heavy vehicles on the street. That is, a vehicle will reject a gap if the gap is provided by a heavy vehicle. That is the basic concept. And this graph shows how critical gap changes with percentage of heavy vehicle in the opposing direction on the major approach. The passenger car unit at uncontrolled intersection is based on the occupancy time and the width ratio. Here speed and area are not considered, rather occupancy time, how much time a vehicle will occupy the conflict area in the intersection. That is important. And what is the width of the vehicle? Rather than length, width of the vehicle is important. And based on that, we suggested some PCU factors for two-wheeler, three-wheeler, standard car, big car and light commercial vehicles and buses, and for 2XL trucks, 3XL trucks, multi-axle trucks and so on. Now the capacity for a particular movement X is determined using this equation. It is modified equation of highway capacity manual method, where A and B are two adjustment factors, and these adjustment factors will depend upon the major street configuration as well as the subject movement. And this is the table which provides you value of A, B for different type of conditions. VCX is the conflicting traffic for movement X, TC is the critical gap, and TF is the follow-up time. Now this estimation of VCX is also different from what is given in US highway capacity manual, and we have given the complete procedure of finding the conflicting flow for each priority movement. This explains only for movement 1 and 4. Now for movement 1, this is the conflicting flow, that is the through traffic from opposite direction. And similarly for movement number 4, V2 is the conflicting traffic. Now level of service at uncontrolled intersections are defined based on V by C ratio. Here delay is not considered because we found that vehicles do not wait in the approach, they try to force their entry, and therefore V by C ratio is much better explanation than any other parameter. The next chapter is signalized intersections, and here two new concepts are suggested. One, estimation of PCU based on optimization technique, and another one is LOS based on delay and user perception. Now here PCU is estimated based on optimization, and the basic concept is that departure from a stop line, departure at a stop line in terms of PCU should be constant in each cycle, and that is how it has been optimized. And these are the final PCU factors which are given, and it is found that they are not dynamic, they are static, and for different category of vehicles these PCU factors are given in the manual. The suggestion flow is given by this equation, this is the base suggestion flow using proportion of vehicle class and road width as input variable, and this is the adjustment factor for bus blockage due to downstream bus stop. This is for adjustment factor for blockage by right turning vehicles in case of exclusive right turn lane, and this is for absence of right turning lanes, and this is the adjustment factor for initial 5-second surge of vehicles. This was observed during observations in the field that motorized two-wheelers try to stand beyond the stop line in some cases, and they move in bulk, they move in groups at the start of the green, and that increases the rate of discharge. So that is the factor FINT, that is initial 5-second surge of vehicles. Delay is estimated by this equation. Here several adjustment factors, or you can say calibration factors, are suggested. M, N and alpha, beta. Alpha is here, beta is here, and N is here. All these are the calibration terms, and D is the average delay per vehicle on particular approach of the intersection. C, cycle length, and lambda is the G by C ratio, where G is the effective green time and X is the degree of saturation, that is volume to capacity ratio. Now this equation, the basic structure of this equation is taken from highway capacity manual of US, and it is calibrated for Indian conditions using these calibration terms M, N, alpha and beta. Now the values of delay calculated from this equation are compared, or you can say modified, through user perception survey. How people basically perceive level of service and delay at intersections, and results of this survey were used to arrive at final values of control delay at different level of service. Now here, if it is less than 20 seconds, it is level of service A, that is the best quality of intersection timings, and if it is more than 130 seconds per vehicle, it is the worst condition. The next chapter is pedestrian facilities, and here we have considered 3 facilities under different land use pattern: footpath or sidewalks, stairways and foot over bridge. Now this is the pedestrian flow parameters for three types of facilities: for stairways, for FOB, and for sidewalk. This is the free flow speed 39 meter per minute, jam density, maximum flow that can take place, optimum density, optimum speed, and space at capacity, that is based on the ellipse, human ellipse. And similar parameters are given for other two types of facilities. The pedestrian level of service is defined for different land uses, for commercial, institutional, terminal, recreational, and residential, and these are the delay pedestrians per minute per meter width of the sidewalk, delay caused to the pedestrians. And this is pedestrian level of service for crosswalk, and this is pedestrian delay in second, how much time the pedestrian is required to wait before starting the crossing of the street, and these are the values for PLOS. And for stairways there are three parameters: flow, speed, and space, and the LOS is defined based on these parameters. And for foot over bridge also the same three parameters, flow, speed, and space, are considered. Another important feature of this manual is introduction of travel time reliability, and this has been demonstrated to work as a performance measure for interurban roads as well as for urban corridors. A complete procedure is given in the manual for determination of travel time reliability and level of service. Finally, the manual was released by our Honorable Minister of Road Transport and Highways on February 12, 2018. Thank you very much for watching this video. If you have any question, you can write in the description box or you can email me.